Today we're on pages 228 and 229 of our textbook, Unit 7, Lesson 4. This is our second day of the geometric definition of a parabola. Write the general equation of a parabola that has a vertical axis of symmetry. This is y equals 1 over 4p times x minus h squared plus k. Remember where the vertex has the coordinates h comma k, and p is the distance from the vertex to the focus, which is the same as the distance from the vertex to the directrix. For each of the following equations of a parabola, state whether it opens up or down, the vertex, the p-value, the focus, and find the equation of the directrix. Number 1, 12 times y plus 6 equals x minus 4 squared. We need to get y by itself. First, get y by itself. Don't distribute the 12, rather multiply both sides by the reciprocal 1/12. In doing so, we then have y plus 6 equals 1/12 times x minus 4 squared. Now subtract 6 from both sides and we have y by itself. Y equals 1/12 times x minus 4 squared minus 6. This represents the equation of a parabola that opens up because the leading coefficient is positive. The vertex, take out the opposite of what's in parentheses, positive 4 and negative 6. Go over to our grid, plot the point for negative 6. Label it V for vertex. We know it opens up. So draw a parabola opening upward. The p-value, 1 over 4p, is equal to 1/12. Cross multiply, 4p equals 12. Divide by 4, p equals 3. From the vertex, count up 1, 2, 3. There's our focus at 4, negative 3. And the equation of the directrix, from the vertex, count down 3. Draw your horizontal line. Y equals negative 9. Number 2, here's our y that we want to get by itself. If I look over here on the right-hand side, these two terms have 8 in common. I could factor out 8 and have 8 times y minus 3 equals x plus 5 squared. Now multiply by 1/8. X plus 5 squared equals y minus 3, and then add 3. We'll have y equals 1/8 x plus 5 squared plus 3. This parabola opens up. The vertex, negative 5, positive 3. Plot the point on our grid. Label it V. Draw a parabola opening upward. the p-value, 1 over 4p is equal to 1/8. 4p equals 8, cross multiplying, so p equals 2. From the vertex, count up 2. Inside the parabola, we have our focus at -5, +5. And count 2 units below our vertex. Draw a horizontal line, y equals 1. Number 3, write the equation of a vertical parabola whose vertex is -4 and p-value is 3. Let's write down our formula of our equation. Y equals 1 over 4p times x minus h squared plus k. In order to substitute into this formula, we need two things: the vertex and the value of p. And that's exactly what we have given to us for number 3. The vertex is -1, 4, and the value of p is 3. Substituting in, y equals 1 over 4 times 3 times x minus -1 squared plus 4. Simplifying, y equals 1/12 times x plus 1 squared plus 4. Write the equation of a parabola with a vertex of -1, 4 and a focus of -1, 6. In this situation, I always need to draw a quick sketch or diagram. The vertex is -1, 4. And the focus -1, 6. Let's label that V for vertex. Well, what's the distance between the vertex and the focus? It's 2 units, so P is 2. And this opens upward. So the leading coefficient is positive. Y equals 1 over 4 times 2 times x minus -1 squared plus 4. Simplifying, y equals 1/8 times x plus 1 squared plus 4. Write the equation of a parabola whose vertex is 2, -3 and focus is 2, -5. Focus 2, -3, plot that point. I'm sorry, vertex 2, -3. Focus 2, -5. Distance between the vertex and focus is 2 units, that is our p-value. Does this open up or down? It opens downward, so our leading coefficient is negative. Y equals, substituting into the formula, 2 for p, -1 over 4 times 2 times x minus 2 squared plus -3. Y equals -1/8 x minus 2 squared minus 3. Number 6, write an equation for the set of points which are equidistant from the origin and the line y equals -6. So this is the definition of a parabola. It's equidistant from a set of all points, equidistant from a point and a line. So equidistant from the origin, this is not the vertex, this is the focus. We have to find the vertex in this question. And this is a directrix. So a sketch, focus, y equals -6. So the distance between the directrix and focus here is 6 units. The vertex would be midway between at 3 units. So P is equal to 3. Here's our vertex at 0, -3. It opens upward. Remember, because the focus is always between or inside the two halves of the parabola. We have the two things we need: vertex 0, -3, p-value of 3. Substituting into y equals 1/4p times x minus h squared plus k. You don't have to show this middle step here. You could go right to the simplified equation if you like. Y equals 1/12 times x squared minus 3. Number 7, write an equation for the set of points which are equidistant from 0, 2 and the x-axis. And equidistant from 0, 2, this is the focus 0, 2, and the x-axis is the directrix. The equation of the x-axis, not that we need it, but it is y equals 0. Focus 0, 2. Directrix is the x-axis. That means our p-value is 1. The distance from the directrix to focus is 2. Divide that by 2. P equals 1. And our vertex is 0, 1. And our parabola opens upward. P is 1, so y equals 1/4 times 1 times x minus 0 squared plus 1. Y equals 1/4 x squared plus 1. And our last question, write the equation of a parabola whose focus is 3, 1 and directrix is y equals 5. This is the focus 3, 1, directrix y equals 5. The vertex is going to be midway between the focus and our directrix. Here it is at 3, 3. This parabola is opening downward, so its leading coefficient is negative, and the p-value is 2. Right, there was 4 units between the focus and directrix. Half of 4 is 2. Y equals negative 1 over 4 times 2 times x minus 3 squared plus 3. Y equals negative 1/8 parentheses x minus 3 squared plus 3. And I thank you for your attention.